Okay, now let's get into the refactored code, and then this is going to be a completely, we're going to try to incorporate the concepts that we learned earlier in the course about functional programming style. Okay, so pretty much the only thing that changed, I'm going to leave this code here in the calculator file. That was the previous code we were using. And in the calculator refactored code, again, it's a blank slate right now. All that changed over here on the index.html. It's calculator refactored. By the way, if you're wondering what I'm using to host the application, it's a little live. I think it's called Live Server for Visual Studio Code. If you're using Visual Studio Code, but if not, just search online. There's like little Python scripts or something that you can just start very minimalistic servers. But again, I have just a plugin installed on Visual Studio Code. I'll look it up and put it in the class notes. That way that you guys have it. But just install it, and then this allows us to just click over here, and then it spins up an app for us, little server. And it's, again, we don't have to install React or anything like that. Again, you don't get all the benefits of, like, the transpiler with like Babel and all that stuff. But again, I think for what we're doing and for understanding these concepts, I don't think it's necessary to install some framework or anything. I think these concepts translate not just across frameworks but across languages as well. So that's the important thing that we want to get from this. Okay. So, anyways, let's get started on the refactored code, and we're going to be using an awesome library. I believe it's created by Microsoft, believe it or not, and it's called the RxJS. Okay, and again, I think in almost any language that you might be writing code in, they have a version of this. So if you learn it in one, it's pretty much reusable anywhere. So, and again, this is actually a very extensive observable. I'm just gonna import a few things from the library just to get us started here um, from event, from pipe. Okay, and then RxJS. So this is a very extensive library, to be honest with you, and and it's a much deeper topic. But essentially, what we're getting into here, it's not just functional programming, but functional reactive programming. And again, if you've ever used React, so we're going to be merging these two concepts now. And pretty much what it allows us to do is use functional programming styles, but at the same time with this library, we're not going to have to write all of these utilities that we were writing before, because they've already done a lot of this work for us. Okay, and again, it has been tested, it has been used in production for I believe many years now. So again, this is kind of what I was trying to explain to you earlier on when I was explaining the concepts. Usually what you want to understand the theory behind functional programming, so that when you do start writing functional programming in that style, that you actually know what's happening under the hood. But essentially, most of these functions and utilities you'll get from a library, and RxJS is just one I happen to like. They're constantly updating it, so it's constantly getting better and better. And it really, again, I might make another class just based on RxJS and about that library itself, because again, it's pretty extensible and it's pretty awesome. So it makes writing functional programming and reactive programming. It makes it really easy and fun to write without us having to go and write all these functions up ourselves. And then we'll see how we can just compose them to create our application, and even reason about our application very differently than in an object-oriented programming way. So give me just a few seconds, and I'm gonna finish just importing everything we're gonna be using here. Okay, so the first thing we want to do is exactly what we did before. So we just want to get a handle on our var keys, and our keys are going to be, actually, let's get a handle to the document first. Okay, so let's go var display, and again, this is exactly what we did in the previous version. Dot get element by ID, and there's the calculator display data. Okay, and then we're going to go keys, get element by class name, and calculator button. All right, then we're gonna go we're going to reassign the keys from what the actual DOM gives us to an array. So we're going to put them in an array. That way, again, we can iterate over them. Array dot from keys, and then var operators. So, okay, already we're going to be thinking about the application a little bit different. So we know, okay, what do we know? We know that we have an application, which again, if we were to break it down into its logical steps, is a set of operations that the user can either click on one of these operators, one of the digits. They could click the calculate button or the clear button, and then we have the display. That's pretty much it, right? That is the core of this application. Okay, so let's go ahead and actually I'm gonna copy this because I have it that way you guys see what I'm going to be doing. So the operators are the division, the actual symbols themselves, okay? Because then we're going to be, again, we're going to be attaching some DOM events to these keys so that when any single event is clicked, then we can get a notification, okay? Okay, and then let's write that, okay? So let's write clicks. So what we want to start thinking when we're thinking in functional programming, and especially functional reactive programming, is that, remember this, this is going to be a set of values that we're going to be getting over time. So instead of storing state and then changing state and all that, we're going to be setting up functions that as they're being called, we're going to get their values out of them, okay? And then what we want to do is we want to compose those values into what our final application is going to be, okay? So the first thing that we're going to do is we're going to create a stream or a collection of all the values that are that can happen in our application, okay? So let's go ahead and do that. So from, and again, now we're using from the Rx library, okay? So from keys, and it's very similar to the JavaScript one. So we just want to put those keys in an actual in one of the operators that Rx gives us. That way we can chain them and we can use the functions one after the other, okay? Then we're gonna go pipe. Now, if you remember the compose function that we talked about earlier, pipe is just like compose, but instead of reading from right to left, then pipe, since we have the data available to us in this instance, then we can go from left to right, okay? So pipe is just gonna do the same thing that compose did. So it's gonna apply each value, okay? And then the functions that we're gonna write in here, they're going to be piped, the output of one into the input is going to become the input of the next, okay? And then let's see how that works. So again, so we're going to use merge map. So merge map, if you remember the map operation, this is the operation we're going to use to iterate over each of the keys. And the keys, remember, they're going to become the actual DOM elements that we want to attach the click event to, okay? So that way, this collection over time, and pretty much what that means is as the user clicks on any of the buttons in our calculator, then we'll get those values out, okay? So that's what merge map is going to do. And then the merge part of it, all it does is going to concatenate them all at once. So because click events are an infinite stream, meaning once we attach a click event can happen at any time. So we can't really know when it's going to end. So that way, what the merge map is going to allow us to do is it's going to say, hey, of all these buttons that we're going to attach this event handler to, whenever something happens on any of them, then just spit out that value, right? Just output that value and merge them all into one single stream. And then, do that for every single one. And that's what the map operation does. So then from there, we're just going to use for another one of the functions that Rx provides for us, which is the from event. Now, the from event function, it's very similar to the actual one that the DOM provides. But in this case, again, since we're going with functional programming, we don't want to attach our functions, again, to the DOM. That way, we've created, or Rx in this case has provided a function that they've created themselves. And under the hood, pretty much what it's doing is the same thing that the DOM one is doing. But in this case, as you can see, it's something that can be exported and used in any context. Now, after we have the click event attached, the next thing we want to do is we want to map them, okay? And then we're going to get an event out of them. So this is the event, the whole event. Now, the whole event is actually, it's a very big object. So we want to kind of filter that down into just a few, or just actually one of the properties, which is the target text content, okay?
So text content, and then let's see if we're getting any output. Okay, so I'm gonna go ahead, and then the way that you get, okay, so the way that you get the output or the result out of Rx, okay, if you're using this library, is that it provides. So once we create a stream, that stream, another way to think about it is a subscription. Okay, so Rx returns a subscription object. Okay, and then to that subscription, okay, or to that stream, any way you want to think about it is fine. You can subscribe to that. Subscribe, and then what you want to pass to it at this point, let's just call it value. We'll change it later to something more meaningful. So console.log, and let's console log the value out. Then let's go into our browser, okay, and let's see if we're getting any feedback. LM is not defined, so let me see if I wrote this correctly. Merge map. Oh, the merge map actually also, yeah. So this is the actual element as we're iterating over our keys. So right as we map over each of them, then that's going to be each single element. So then let's go back here and let's see what we're getting back in the console. So over here in the console, as you can see, now we're getting a stream of every single key in our calculator. Okay, so this is, again, this is this right here. We're going to call it clicks. So this is a stream of all the possible clicks, of all the possible keys in the calculator, right? So this pretty much tells us that, hey, we've attached the click event to everything in the calculator. Now the next thing we want to do is we want to think about this in logical steps. Okay, so let's write another function that lets us know if the actual key that was pressed is a number or is an operator. Okay, so let's first write the number one, the isNumber function. So the isNumber function is going to subscribe to the click source, right? So if you remember in Rx, first we have to have a source. Okay, in this case the source is keys for the first one. In the second one, since we've already created a stream, we're going to subscribe just to that stream. Okay, and we're going to say clicks.pipe. So we're going to use the pipe utility again, and then what we're going to say is we're going to filter it. And if you remember how filter works, it's very similar to map. Okay, so you can iterate over a collection, and in this case, if you remember, it's going to be all the events. Okay, so all we want to do is we want to say is nan, so is nan, and over here we want to say, so if it's not, okay, if it's not a number, then this is going to return true. But then since we have the bang operator over here, it's going to return false. So actually what we're saying is just tell us what is a number, okay, and then we can come over here, or actually just notify us of the things that are a number. So if we click now on an operator, that should not console log anything to the console. Okay, so we shouldn't see anything in the console if we're just clicking around over here. Now, as soon as we click on one of the digits or one of the numbers, we should see something in the console, and exactly we do. Okay, so there you go. That's our function that lets us know out of all the clicks. Now we're filtering down in that stream, in this specific stream. What we have is just a stream of all the actual numbers and nothing else. Okay, now what's the next one you think we're going to write? Let's write the one that is operator now. Okay, so now we want to know, since we have one stream, okay, that's the numbers. Now we're going to create another one, the is operator. And then for that one, we're also going to subscribe to the click. So remember, the click source is the one that has them all. Okay, so that's the one we have to subscribe. We can't subscribe to this number because the is number one has already been filtered down to just the numbers. Okay, so we have to subscribe to the above one, which still is the source of all the stream events. And then what we're going to do is we're going to perform another filter operation. We're going to call it value. And then what we're going to do is we're going to check if the value that we got out of one of these clicks is actually in here. So if it's one of the operators, essentially, so we're going to check for. And the way we do that is pretty simple. So we're just going to go operators that includes, and then we're going to pass the value to it. Okay, and then let's subscribe to that source. And then we should see exactly at this point the opposite of what we saw for numbers. So now when we actually click a number, we shouldn't see anything outputted to the console. But as soon as we click on any of the operators, okay, we should see that result in the console. And that's exactly what we see. So now that we have the is number and the is operator, the only thing left for us to write is the is calculate. So now we want to know when someone pressed the equal sign. Okay, it's calculate. It's calculate. I'm just making sure I spelled that correctly. So again, we're going to subscribe to the clicks, right? Because that's the one that gives us all the actual events. And we're going to perform another filter operation, but in this case, the operation we're going to perform is actually going to be value equals equals, and not we don't want to assign it. We want to check if they're the same. So if they're actually the same. So it's an equality operator, not a assignment operator. So okay, and then let's subscribe to it. Okay, so there's calculate, and we're gonna come down here and subscribe to it. Okay, and then so if we click on anything, the operators, anything, whatever, we shouldn't see anything. So now the only thing we want to see in the console is the equal sign, and again, that is exactly what we do. So now we pretty much okay. So let's review what we've done so far. We have the clicks event, which actually outputs everything that's actually clickable. Okay, and we attach an event to everything at first. Then what we want to do is we want to create 3 separate streams. Okay, and those streams are the logical things that we're gonna need in order to compose the expression that the user then is going to want to calculate. And for us to do that, remember the pattern that we want to follow is it needs to be a number first, then followed by an operator, and then at the end they'll click the calculate whenever they're ready. So after that, but essentially now we can check if if it was a number, then an operator, then if they click calculate. And now since we have them in separate streams, we can actually put them in the order that we want, and then that's what we want to do now. So now let's create the inputs which will be a function. Okay, so let's go ahead and create the inputs function. And the inputs function, what we want to do is we want to do exactly what we just said. Okay, we want to make sure that everything comes in the order that we want. First, it must be a number followed by an operator, and then another number. Right? We know once we have that pattern, we can then go ahead and calculate. So if we have 5 plus, and then they click on equals, we know we don't have that pattern yet, right? So it must be a number followed by an operator, and then followed by another number. Okay, so we're gonna go is number, and then what we want to do is we're gonna say dot pipe. Okay, and then what? So remember, now we're saying, hey, we want to subscribe to the is number source, but really what we want to do is we want to get all those streams that we just created, and we want to merge them together. Okay, so is operator, and again we saw the merge operation above, and the is calculate, right? So the merge operation, unlike merge map, which over here we actually wanted to do a projection function. If you remember the map operation, you provided a projection function. In this case, we wanted to go from simple elements that we got and convert them into an actual element with a click event attached to it, and that's what we use the merge map. Over here, we're using just the merge because we have 3 streams, and all we want to do at this point is merge them together. But when we merge them together, okay, we're gonna use, if you remember the reduce function that I showed you earlier, this one is going to be very similar to reduce, except that in Rx, since we're getting events over time, and it's not something that at the beginning there are no inputs to reduce over, right? So like when the display is 0, there's really nothing to scan over. So this is not something that we want to start immediately, right? We just wanted to, once a value comes in here, then we want this operation to be performed. And that's, again, this is one of the power that you get with functional programming is we can do all this setup right now. But again, remember at the beginning, the state of the calculator, as we're writing it right now, it's going to be 0, right? So this is not something that's going to be done immediately. This is something that is going to be done only once something comes through one of the streams that we have created. And then all we want to do is we want to say, hey, we want to concatenate them together. So we want to say get whatever was previously there. So if it was 15 and then they click plus, then we want to make sure that it says 15 and then the plus and then whatever number they put after, right? So now we're creating the expression that we're going to eventually calculate. And then we're going to use a function that you haven't seen before, but it's pretty self-explanatory. And this is, again, something that Rx provides for us. So we're going to say, hey, as long as they keep putting, okay, a number followed by an operator, followed by a number, followed by an operator. So even if the user inputs something, for example, 1 plus 1, and then they, instead of clicking equals, they click times 15 divided by 2. So all that, we want to make sure that all that gets calculated at the end, right? So because they can have an expression as big as they want, right? It doesn't just have to be a binary expression where it's just a 1 plus 1 or a 2 times something or a 3 divided by something. It can be a complex expression, as in, you know, multiple operators and then multiple numbers as well. So that's why we want to say, hey, you know what? As long as they keep adding a number by an operator, take, you know, all those streams, put them together until they actually, until the value dot includes, and then we want to say until they click this, which is the equal sign. And what we want to say is we can pass it a second argument here, which again, if you go over the RX docs that I'll provide for you in the class notes, you can check the take while and the function signature as it's supposed to be done. But if we provide the second value, what we're telling it is, hey, that last number that, like, although we're going to scan over each value, we don't want the intermediate values, right? We just want the final output right before they clicked, or up until the point that they click the equal sign. And that's what we pass through. If we pass false to this, then we won't get that that final value. So now let's go ahead and subscribe to that function. And then what we're going to do is we're going to say, hey, 15. Great. So they're being concatenated together. Let's say plus 1. And then we got 15 plus 1. And then let's see if we go times 10. And then we get 15 plus 1 times 10. And then once we click equals, then we get 15 plus 1 times 10 equals. And then if we click anything else, we shouldn't see anything else being outputted to the console. And that's exactly what we see, right? So after this equal sign gets clicked, now the only thing that should be able to press, and the only thing that, you know, that they should see is the actual expression calculated back on the screen, right? So at this point, we want to show them the result of their expression. So then once we got that, then the final thing is displaying it to the screen pretty much. So we're going to subscribe to the inputs. And then what I want to do is I want you to check. Okay, so now up until this point, pretty much this is the pure part of the program. So at this point, all we have is streams, right? And then we're composing those streams together to create new streams. But really, up until this point, we haven't done any mutation, right? So now that we want impure part of our programs, so in this part of our program, really, this is the part that's interoperable. This is the part that we can pass around, and we can do everything with this part. But now that we want to actually affect the DOM, that's where we want this part of the program to live, essentially, which is so that way we know, hey, this is where our bugs can happen, and they could happen, right? But it's, again, like we said, it's not just that bugs can happen, but now we can reason about our program in a more logical sense, okay? And then we know that anything that we're going to manipulate is going to be in this part of the program, whereas everything in this other part of the program is, you know, we're not manipulating. We're pretty much getting the data and then changing it, but we're not affecting anything outside of the functions themselves, okay? So we're going to say inputs.subscribe, and then we're going to say the value, whatever the value is at that point, we're going to say display.value, and then we're going to say make it equal. So at this point, we are doing an assignment operator. We're going to say make it equal to whatever the value is at that point. So if we come back over here, now we are actually getting on display and not just console logging it out, okay? So now, before we were using the console log just to debug, but at this point, what we actually want is to affect the DOM and change what's on the display. So we're going to say 10 plus 1 times 5, let's say. And then we're going to press equals. So at that point, we see the full expression, which is exactly what we were getting on the console. We see it displayed on the display. Perfect. So now we're going to say the expression dot subscribe x, and then we're going to say display dot value equals eval. And if you are familiar with JavaScript, you know that the eval function, it's something that should be used sparingly, but in this case, it actually works for what we're trying to do, which, again, since we're going to be getting a string at this point in the display, what we want to do is not export, but expression. So this expression function, this is another one final string that we want to create. And pretty much what it's going to be the final expression minus the equal sign, right? Because we can't we can't evaluate that that equal sign. So we want to say, hey, this is perfect, what we had up until that point, but we want to like slice off the end that that equal sign, because what we actually want is to evaluate the expression without the equal sign. So we're gonna say take the last, okay, take last one. So what this take last function does is, if you remember, as we were writing out to the console, because the scan operation gives us every intermediate value up until the point that we get the equal sign, and then it includes the equal sign because we asked it to. What we want to do is we want to say, hey, forget about all the intermediate values. I mean, we want to do all this operations on it for sure. So that's what we're using the scan operation for. But at the end, when we're actually going to go ahead and evaluate the expression, we need just a final value in this stream. At least in this stream, the input stream can stay the same, right? But for the actual evaluation piece, we want to create a new stream that just takes the final value of the scan operation, and then we're going to map over that, and we're going to say that's, whatever that is, which we know it's going to be the expression plus the equal sign. We're going to say, hey, slice of the end that equal sign, so we can evaluate it for the user. And for that, we use the slice method, and we go from 0 to -1, which is 1 minus the index of that string. And then we can go ahead, comment this out, and then we're going to say xpr, which is the expression, and then we're going to subscribe to that and see if everything is working. So now we're going to go 5 times 4 plus 1. So that should give us 20 plus 1, 21. We're going to click on equals, and there you go. Now we get the number 21 out. And that's pretty much it. So we have pretty much, okay, I'm going to delete these comments for a second, and I'll add them back just so I can make a point over here. So we went from, and I'm going to open up the calculator file as well. So we went from an application that essentially, okay, and again, if you look over here, I'm going to kind of fold this in so we can see how big the line numbers are. And we can see that this one function, the keys array for each, actually is 100 lines of code, right? And then again, based on everything that we learned before, and I know for this exercise, this is exactly what we wanted to prove, which is, the changing state and all that. So, we kind of made it convoluted on purpose. But again, this is what a lot of people, this is what a lot of code looks like in the wild. And again, like I said, when we're learning, and I'm certainly not, I'm certainly guilty of it myself, this is, this is what you can expect. And so you can go over your code and start refactoring it from, a function that essentially is 100 lines of code and is storing state in like objects and then changing it somewhere else, and then you have to have all this if else branch logic going on. And again, maybe at the point that you're writing the program, it makes complete sense, but try to come back like a month later or 2 months later and then try to reread your code, and you're gonna have to make sense of it all over again, right? Because it's not separated into logical parts. Whereas the refactor code, okay, it's only 47 lines of code, the whole thing, and each of our functions are just 2 or 3 lines, okay, maybe 4 at most, and they all really make sense, right? This is the clicks events. This is that event filtered out and to just being the numbers. This is that same click event filtered out to just being the operators. This is that same first event filtered out to just being the equal sign. Then we compose them together, right? So we say merge them, scan them, which is a reduce function, add them, put them together, and then up until the point that we get an equal sign. Then, to get us the final expression, everything that we got up to that point minus the equal sign, and then we can just subscribe to that and display it on the display, right? So I'll put it to the DOM essentially and affect the DOM. But we see that only this part of this is just the impure part of our program, and there's nothing wrong with the impure or pure part. It's just that we want to make logical, okay? We want to make it for us to be easier to read and reason about, so that when we either come back, and this is the pure part, and again, we don't really want to get hung up too much on the names. This is just a part that has no side effects, right? And we're just using the data and then moving it around. And then over here, what we're actually doing is the part with side effects. That's all it means. Okay, so let's not get hung up too much on the words. I honestly don't know where the words come from, but it's irrelevant. What we want to grasp, okay, is the idea behind these words, which is for this part of the program, all we're doing is getting some data and then moving it around. okay? But we're really not affecting anything outside of the functions themselves. That's why we can subscribe to each of the functions and know exactly what's going to come out. And then on this other side of the program, where we're actually want to make some change and actually give the user some feedback. So this is, again, a very important part of the program. It's just we want to have them in parts that, they're not kind of a spaghetti code all over, right? So like it's not like we don't have to make sense of it in this fashion, which again, at the point that you're writing the program, maybe will make complete sense, the decisions you made. But a month later or 2 months later or even a year later or whenever, you're maybe onboarding someone onto the code, like you have to like walk them through this, and it becomes very very difficult, especially when the functions are like 100 lines, right? So you have to explain a 100-line function, whereas over here you only have to explain a single piece of the function at one point, and they kind of make logical sense anyways, right? So that's again, maybe your whole code can be refactored into a functional style, but you can get pieces of it and start refactoring, and over time just get better at it, and you'll see that your programs will become easier to understand. And again, if nothing else, at least now you know what other functional programmers are talking about when they talk about all these concepts of pure, impure, and function composition over inheritance and all that stuff, right? So again, it's not really that difficult. There's not really that much magic, but I think at the end it is a powerful concept to understand, especially if you're going to be programming. And again, you see that our whole program really became, without these comments, about 47 lines of code, as to compared to like 140 something lines of code, or 124 lines of code. So we wrote the same program. And again, there's still things that we should finish about this calculator. So by no means is this like an extensive program, but it kind of shows it kind of shows what we wanted to show anyways, of the power of functional programming, and how easy our programs can become. The same program can be written in about a third of the code, and less code is always easier to make sense of. So anyways, hope you liked the lesson. Okay, if you have any questions, please let me know in the comments or the reviews, and I'll come back and update the lessons if necessary. I'll make new videos, and really, I hope you you enjoy the course. Read over the course materials that I'm going to be providing to you, because all these concepts, this is just the beginning, but you can go into much depth into each of the topics. Okay, so anyways, thank you for attending the course, and I'll catch you in the new one when we make new ones. All right, take care.